Azure Landing Zones Explained, the secure foundation every cloud adoption strategy needs.
Hello and welcome. Today we are going to take a deep practical look at Azure landing zones and why they matter so much in a successful cloud adoption journey. A landing zone is not just a technical deployment, and it is not just a set of Azure subscriptions. It is the foundation that helps an organization move from scattered cloud experiments to a secure, scalable, governed, and operationally ready Azure environment. In the Microsoft Cloud Adoption Framework, the landing zone belongs to the ready phase because before workloads move into Azure, the environment itself must be prepared. That preparation includes identity, governance, networking, security, management, cost visibility, automation, and clear ownership across teams. The attached Microsoft Cloud Adoption Framework document describes Azure landing zones as the recommended starting point for preparing Azure for workloads and explains that they provide a structured approach for building a scalable, secure, and governed cloud environment from the start. To understand a landing zone, think about how a city is built. A city does not begin with random buildings placed wherever space is available. It starts with roads, zoning rules, electricity, water, emergency services, addresses, security, and public infrastructure. Azure works in a similar way. Workloads such as applications, databases, analytics systems, virtual desktops, AI services, and migrated enterprise platforms need a prepared environment around them. That environment must define how resources are organized, who can access them, how traffic flows, how security is monitored, how costs are tracked, and how compliance rules are enforced. A landing zone creates this foundation so every workload does not have to solve the same platform problems from scratch. The main purpose of an Azure landing zone is to create consistency without removing flexibility. This balance is important because cloud adoption usually involves many teams moving at different speeds. Security teams want control, platform teams want standardization, application teams want autonomy, finance teams want cost visibility, and business leaders want faster delivery. A landing zone helps all of these groups work together by providing shared guardrails. Application teams can deploy workloads, but they do so inside an environment where identity, networking, policy, monitoring, and security expectations are already defined. This reduces confusion, lowers risk, and helps organizations scale cloud adoption without creating cloud sprawl. Azure landing zones are built around two major concepts: the platform landing zone and application landing zones. The platform landing zone provides the shared foundation used by many workloads. It includes services and controls for identity, connectivity, management, security, and governance. Application landing zones are where workload teams deploy application resources. This separation matters because the platform and the workloads have different life cycles, different owners, and different risk profiles. A firewall, identity service, logging workspace, or management group structure should not be managed the same way as a single application database or web app. By separating platform responsibilities from workload responsibilities, organizations can make ownership clearer and operations more reliable. The platform landing zone is the backbone of the Azure environment. It usually contains shared services that many workloads depend on, such as network connectivity, identity integration, monitoring, security tooling, policy assignments, and platform automation. In many enterprise designs, this includes dedicated subscriptions for connectivity, identity, management, and security. The connectivity subscription may host hub networks, firewalls, private DNS, ExpressRoute, VPN gateways, or routing components. The management subscription may contain monitoring, alerting, logging, automation, dashboards, and operational tools. The security subscription may host security analytics, Microsoft Sentinel, or other security resources. The identity subscription can support identity-related infrastructure where required. The exact design depends on the organization, but the principle is the same. Shared services should be planned, governed, and operated as a platform. Application landing zones are the environments where workloads live. A workload might need separate environments for development, testing, staging, and production. Each environment may use one or more subscriptions depending on scale, compliance, limits, ownership, and isolation requirements. Application landing zones inherit governance from management groups, which helps ensure consistent policies across many subscriptions. For example, a production workload might inherit stronger security and monitoring policies than a sandbox environment. An internet-facing application may sit under an online management group, while an internal application may sit under a core management group. This structure allows workload teams to move quickly while still following organizational standards. One of the most important design areas in an Azure landing zone is resource organization. This includes management groups, subscriptions, resource groups, naming standards, tagging standards, and ownership models. Management groups allow policy and access controls to be applied above individual subscriptions. Subscriptions provide boundaries for billing, security, service limits, and operational ownership. Resource groups help organize related resources inside a subscription. Naming and tagging make resources easier to identify, manage, report on, and govern. Without a clear resource organization model, cloud environments can become difficult to understand very quickly. A landing zone gives the organization a structure that can scale from the first workload to hundreds or thousands of workloads. Identity and access management is another core part of landing zone design. In cloud environments, identity is often the most important security boundary. A landing zone should define how Microsoft Entra ID is used, how role-based access control is assigned, how privileged access is managed, and how access reviews are performed. It should support least privilege, just-in-time access, multi-factor authentication, and separation of duties. Platform teams should have the permissions needed to manage shared services, but not unlimited access to every workload. Application teams should have enough access to operate their workloads, but not enough to bypass enterprise controls. Security teams should have visibility and authority to monitor risk. A strong identity model reduces the chance of accidental exposure and helps support zero trust principles. Networking is often one of the most complex parts of a landing zone because workloads rarely operate in isolation. Some applications need private connectivity to on-premises systems. Some need secure internet ingress and egress. Some need private endpoints, DNS integration, hub-and-spoke networking, virtual WAN, Azure Firewall, network security groups, user-defined routes, or DDoS protection. A landing zone helps define approved network patterns, so every team does not invent its own architecture. This improves security, reduces troubleshooting time, and makes connectivity easier to govern. The goal is not to force every workload into the same network design, but to provide standard patterns that match common needs such as internal applications, public applications, hybrid workloads, and regulated workloads. Governance is where landing zones turn organizational rules into repeatable controls. Governance includes policies, compliance requirements, tagging rules, allowed regions, allowed services, naming conventions, security baselines, and deployment standards. Azure Policy can help enforce these rules automatically. For example, policy can require diagnostic logs, restrict public IP creation, enforce specific regions, require tags, deny unapproved resource types, or audit encryption settings. This is important because manual governance does not scale. If every workload needs a human review for every control, cloud adoption slows down. A landing zone uses automated governance, so teams receive fast feedback and stay inside approved guardrails from the beginning. Security must be built into the landing zone from day one. In the cloud, every resource can become part of the attack surface if it is not configured correctly. A landing zone should support security baselines, threat detection, monitoring, logging, secure network design, identity protection, encryption standards, and policy-driven controls. Microsoft Defender for Cloud, Microsoft Sentinel, Azure Policy, Microsoft Entra ID, Key Vault, private networking, and diagnostic logging can all play roles in the security design. The landing zone should also reflect the shared responsibility model. Microsoft secures the cloud platform, but customers are responsible for secure configuration, identity, data protection, access management, application security, and operational response. A secure landing zone helps clarify these responsibilities before workloads are deployed. Management and operations are just as important as deployment. Many organizations successfully move workloads to Azure, but then struggle with monitoring, alerting, backup, updates, incidents, cost reviews, ownership, and operational support. A landing zone should include management capabilities from the start. This includes Azure Monitor, log analytics, service health alerts, backup policies, update management, inventory visibility, performance monitoring, and operational dashboards. Platform teams may monitor shared services such as networks, firewalls, and identity infrastructure, while application teams monitor application performance and user experience. This shared operating model helps reduce blind spots and improves incident response. The landing zone should make operations predictable rather than reactive. Cost management is another essential landing zone capability. Cloud cost problems often begin when resources are deployed without structure ownership, tags, budgets, or reporting. A landing zone can help by organizing subscriptions around ownership and accountability, requiring cost-related tags, enabling budgets, and giving finance teams visibility into cloud consumption. This supports FinOps practices where finance, engineering, and operations teams collaborate to maximize business value from cloud spend. The goal is not simply to spend less. The goal is to understand what is being spent, who owns it, why it exists, and whether it supports business outcomes. A well-designed landing zone makes cost visibility part of the environment rather than an afterthought. Automation is what makes landing zones scalable. A landing zone that is created manually might work for one or two subscriptions, but it becomes difficult to maintain as the environment grows. Infrastructure as code allows the platform to be deployed, reviewed, versioned, tested, and updated consistently. Tools such as Bicep, Terraform, Azure Verified Modules, GitHub Actions, and Azure DevOps pipelines can help platform teams manage landing zone components in a controlled way. This approach treats platform configuration like software. Changes can go through source control, peer review, automated testing, and deployment pipelines. That reduces drift, improves auditability, and makes it easier to evolve the platform over time. Subscription vending is a key capability in mature landing zone environments. Instead of manually creating subscriptions for every new workload, platform teams can automate the process. A subscription vending workflow can create the subscription, place it under the correct management group, apply policies, configure networking, assign roles, enable monitoring, and prepare the environment for deployment. This turns the landing zone into a self-service platform. Workload teams no longer need to wait for manual setup every time they need an environment. At the same time, the organization still gets consistent governance and security. Subscription vending is one of the clearest examples of platform engineering applied to cloud adoption. The landing zone journey usually happens in phases. First, the organization bootstraps the Azure environment by preparing the tenant, billing structure, initial subscriptions, and basic access model. Second, the platform landing zone components are deployed, including management groups, policies, connectivity, identity integration, monitoring, security, and governance controls. Third, subscription vending is introduced to create application landing zones in a repeatable way. Fourth, workload teams deploy application components into those landing zones. The attached Cloud Adoption Framework document describes this journey as progressing through environment bootstrap, platform landing zone deployment, subscription vending, and application landing zone deployment. Landing zone design should start with business strategy, not just technical templates. Before choosing architecture patterns, leaders should understand why the organization is adopting cloud. Is the goal data center modernization, resilience, AI innovation, cost transparency, faster product delivery, global expansion, or security improvement? These motivations affect landing zone decisions. A company prioritizing regulated data may need strict region controls and strong audit logging. A company prioritizing developer velocity may need self-service subscriptions and internal developer platforms. A company migrating from data centers may need hybrid connectivity and staged migration waves. The landing zone should support business outcomes, not exist as a generic technical exercise. A landing zone must also align with the cloud operating model. In a centralized model, one cloud team manages most platform and workload operations. This can provide strong control, but it can slow delivery if the central team becomes a bottleneck. In a decentralized model, teams own more of their own cloud environments, which can increase speed but also increase risk if skills and governance are inconsistent. In a shared management model, platform teams provide standard services and guardrails, while workload teams operate independently within those boundaries. For many enterprises, shared management is the most balanced model because it supports both standardization and agility. Platform teams should treat landing zone capabilities as internal products. This means the platform is not just a one-time project delivered and forgotten. It should have a roadmap, backlog, documentation, service catalog, support model, success metrics, and feedback loops. Examples of platform products include subscription vending, standard network patterns, reusable infrastructure modules, policy baselines, monitoring templates, secure deployment pipelines, and developer environment blueprints. When platform teams work this way, application teams become internal customers. The platform team focuses on making secure cloud adoption easier, faster, and more repeatable. This approach aligns closely with the modern discipline of platform engineering. Landing zones also help organizations manage hybrid and multi-cloud realities. Many enterprises do not move everything to Azure at once. Some workloads remain on premises because of latency, regulation, technical dependencies, or timing. Others may run in different cloud providers. A landing zone can support hybrid connectivity, centralized identity, monitoring governance, and security visibility across environments. Azure Arc can extend Azure management to on-premises and multi-cloud resources, helping organizations apply consistent operational practices beyond Azure native resources. This does not mean every environment becomes identical. It means the organization can create a more unified control plane for visibility, governance, and management. Another important topic is landing zones for migration. When organizations migrate existing workloads, the landing zone must be ready before production migration begins. Migration teams need target subscriptions, network connectivity, identity integration, monitoring, backup, cost tracking, security baselines, and governance policies. Without these foundations, migration can become a series of one-off deployments that create technical debt. The landing zone should support migration waves, where workloads are grouped based on dependencies, business priorities, technical readiness, and risk. It should also support different migration strategies such as rehost, replatform, refactor, re-architect, rebuild, replace, retire, and retain. The landing zone provides the destination environment where these strategies can be executed safely. For cloud-native development, landing zones play a slightly different role. Cloud-native teams may not be migrating old systems, but they still need secure and governed environments. They need fast access to approved services, identity patterns, CI/CD pipelines, observability, cost controls, and security guardrails. A startup or innovation team may begin with a lightweight landing zone, focusing on resource hierarchy, access control, basic policy, and cost visibility. As the organization grows, it can add more advanced capabilities such as hub networking, private connectivity, centralized logging, security operations, and subscription vending. This incremental approach allows teams to move fast without ignoring future scale. Landing zones are also relevant for AI workloads. Many organizations ask whether AI requires a separate landing zone. In most cases, the better answer is that AI workloads should use the same Azure landing zone foundation with additional workload-specific controls. AI systems often introduce special concerns around data access, model governance, private networking, content safety, responsible AI processes, cost monitoring, and compliance. The landing zone already provides the foundation for identity, networking, security, governance, and monitoring. The AI workload architecture then builds on top of that foundation with controls appropriate for data pipelines, model endpoints, vector databases, AI agents, and analytics platforms. A landing zone should support regulatory and compliance requirements from the beginning. Compliance may affect region selection, data residency, encryption, audit logging, access reviews, retention policies, network isolation, and incident response processes. Industries such as healthcare, finance, government, energy, and defense often have stricter requirements than general commercial workloads. Azure Policy, Microsoft Purview, Microsoft Defender for Cloud, Microsoft Sentinel, Key Vault, and Management Group Policy Inheritance can help enforce and monitor compliance. However, tools alone are not enough. The organization must define which regulations apply, who owns compliance decisions, how evidence is collected, and how exceptions are approved. Business continuity and disaster recovery should also be considered in landing zone planning. Not every workload needs the same level of resilience, but the platform should support resilience patterns where required. This may include availability zones, region pairs, backup vaults, recovery services, multi-region networking, traffic management, replication, and tested recovery plans. The landing zone should make it easier for workloads to adopt the right resilience pattern based on business impact, recovery time objective, and recovery point objective. Resilience should not be guessed after deployment. It should be connected to business requirements and documented during planning. Landing zones also need strong logging and observability design. Logs are essential for troubleshooting, security investigations, compliance audits, performance analysis, and operational improvement. The landing zone should define where platform logs go, where application logs go, how long logs are retained, who can access them, and which alerts are required. Some logs may belong in centralized workspaces for security and platform operations. Other logs may remain with application teams. The design must balance central visibility with cost, privacy, and operational ownership. Without a log strategy, organizations may either miss critical events or collect too much data without knowing how to use it. Policy design requires careful thinking. Too few policies create risk, but too many restrictive policies can frustrate teams and slow adoption. A good landing zone starts with core policies that protect the environment from high-risk configurations. Over time, policies can become more mature and more specific. Policies should be tested before broad deployment, and exceptions should follow a documented process. Audit policies can be used before deny policies to understand impact. This staged approach reduces disruption and helps teams adapt. Governance should feel like a safety system, not a punishment system. The best landing zones make the secure path the easiest path. Naming and tagging may sound basic, but they become very important at scale. Names help humans understand resources quickly. Tags help with cost reporting, ownership, automation, compliance, and lifecycle management. A landing zone should define required tags, such as owner, cost center, environment, application name, data classification, business unit, and criticality. It should also define naming patterns for subscriptions, resource groups, networks, and common resource types. These standards should be enforced or audited through policy where possible. When naming and tagging are inconsistent, even simple questions become hard to answer. Who owns this resource? Is it production? Can it be deleted? Which application uses it? A landing zone helps answer those questions. Security operations should be connected to the landing zone design. It is not enough to enable security tools. Teams must know how alerts are triaged, who responds to incidents, how evidence is collected, and how actions are escalated. A landing zone should support security monitoring across platform and application resources. It should also support integration with incident management, ticketing, automation, and threat intelligence processes. Microsoft Sentinel and Defender for Cloud can provide strong capabilities, but the operating model determines whether alerts become meaningful action. Security must be both technical and organizational. A landing zone should also account for service limits and subscription scale. Azure subscriptions have quotas and limits for different services. Large workloads, high-scale platforms, and enterprise environments may need multiple subscriptions to avoid limits, isolate risk, separate teams, or manage cost boundaries. Application landing zones may use multiple subscriptions for production, non-production, networking, data, or regional separation. Planning for scale early avoids painful restructuring later. This is one reason subscription vending matters. It makes it easier to create new subscriptions in a consistent way as demand grows. The landing zone should support secure software delivery. Modern cloud environments are not only operated through portals, they are built through pipelines, templates, repositories, and automated workflows. A good landing zone should integrate with DevOps practices such as source control, pull requests, automated testing, deployment approvals, secret management, and environment promotion. Infrastructure as code should be used for platform resources and workload environments where practical. This gives teams repeatability and reduces manual configuration drift. It also improves security because changes are reviewed, tracked, and auditable. Landing zones should not ignore developer experience. If the platform is secure but too difficult to use, teams may look for shortcuts. Good landing zones provide clear documentation, reusable templates, approved patterns, self-service workflows, and fast onboarding. Developers should know how to request an environment, how to connect to shared services, how to deploy securely, how to view logs, how to manage secrets, and how to handle cost expectations. The platform team should remove friction while keeping guardrails in place. This is how landing zones support both governance and innovation. Brownfield environments require special care. Many organizations already have Azure subscriptions before they formally adopt landing zone architecture. These environments may contain production workloads, inconsistent policies, unclear ownership, and manually configured networking. A brownfield landing zone effort must assess the current state, identify gaps, prioritize remediation, and migrate subscriptions into a better structure carefully. Not everything can be rebuilt immediately. Some subscriptions may need policy exemptions, staged remediation, or temporary patterns. The goal is to move toward the landing zone target architecture without disrupting critical workloads. Greenfield environments are easier in some ways because the organization can start clean. A greenfield landing zone can define management groups, subscriptions, policy baselines, network topology, identity patterns, and automation before workloads arrive. This reduces technical debt and creates a strong foundation. However, greenfield projects still require business alignment. Teams must avoid over-engineering the first version. The landing zone should be strong enough to support near-term workloads and flexible enough to evolve. Starting with a reference architecture and tailoring it to real requirements is usually better than trying to deploy every possible capability immediately. A successful landing zone program needs clear roles and responsibilities. Platform teams may own the landing zone architecture, shared services, automation, and subscription vending. Security teams may own security baselines, incident response, threat monitoring, and risk guidance. Governance teams may own policy standards, compliance mapping, and exception processes. Network teams may own connectivity, routing, DNS, and firewall architecture. Application teams own workload design, deployment, reliability, and application operations. Finance teams support budgets, reporting, and cost optimization. Without clear responsibility mapping, even a technically strong landing zone can fail operationally. Landing zones should be validated through testing. Platform teams should test policy assignments, network routing, role assignments, logging, deployment pipelines, subscription vending workflows, and monitoring alerts. Testing should include both expected deployments and block deployments. For example, teams should confirm that approved resources can be deployed successfully and that unapproved configurations are denied or audited as intended. Canary subscriptions can help test changes before they affect many workloads. This reduces the risk of platform updates breaking application delivery. A landing zone is critical infrastructure, so changes should be tested with the same discipline used for important applications. Documentation is a major success factor. A landing zone should include documentation for architecture decisions, management group hierarchy, subscription model, network patterns, policy assignments, access model, security baseline, logging strategy, cost model, exception process, and onboarding steps. Documentation should be practical, not just theoretical. Workload teams need to know what they can deploy, how they request changes, how they get access, how they troubleshoot connectivity, and where they find approved templates. Good documentation reduces support tickets and helps new teams onboard faster. It also helps auditors, leaders, and partners understand how the environment is controlled. Landing zone maturity should grow over time. The first version might focus on core structure, identity, basic policy, cost visibility, and monitoring. The next version might add subscription vending, stronger automation, private networking, security operations, and standardized workload patterns. Later versions might introduce internal developer platforms, advanced FinOps reporting, AI governance, cross-cloud operations, and automated compliance evidence. This maturity model is important because organizations do not need to solve everything on day one. They need to build a foundation that can evolve without major rework. Common landing zone mistakes include starting with technology before strategy, copying reference architecture without tailoring it, mixing platform and workload responsibilities, relying too much on manual setup, ignoring cost visibility, underestimating networking complexity, delaying security involvement, and treating the landing zone as a one-time project. Another common mistake is making governance so restrictive that teams cannot deliver. The opposite mistake is making governance too loose and allowing uncontrolled sprawl. The best landing zones find the right balance for the organization's maturity, risk profile, and delivery needs. The practical takeaway is this: an Azure landing zone is the operating foundation for cloud adoption. It connects strategy, governance, security, networking, identity, management, cost, automation, and workload delivery into one coherent environment. It helps organizations avoid chaos as cloud usage grows. It gives platform teams a scalable way to support many workloads. It gives application teams a safer and faster path to deployment. It gives security and governance teams consistent visibility and control. Most importantly, it turns Azure from a collection of resources into a managed cloud platform. If cloud adoption is the journey, the landing zone is the road system, the safety framework, the control plane, and the launchpad for everything that follows. Thank you for watching.